bank transactions before electronic banking. And it looked like a typewriter. There were these typing machines, and the Nazi government took them over. Anyway, so the Allies worked really hard to uncode it. It was a big deal. My mom's family myth is my mother was good at math and science, so she was good. So they said. That aside, over the years, I met several of these women, and they're lovely, very nice people. But with all due respect to everybody else in this picture, really, who's got the best hands? Who has the best legs? Really. Being objective here. There's my mom. And now I motivate. Yes. Yes. We are in engineering school. Right? My dad to choose to live through the thing. So he was in prisoner of war camp for 4 years, 44 months, longer than anybody else from the U.S. And they had no watches or clocks or jewelry. They all got confiscated. So my dad spent a lot of time, apparently, watching shadows of the sun. And he came back fascinated with sundial. So he invented the sand dial, which you take to the beach so you don't get sand in your watch. He wrote articles for the Evening Star newspaper about the nature of sundials and how fabulous they are. And then when he wrote the book about sundials, yes, people, that's when he was given a lifetime membership in the North American Sundial Society. Yes. Yes. Now, I meant there's some operations research people here, industrial engineering management, Gantt charts. Yeah, all right. Well, and you know how exciting those parties are, right? You get the statistics people together, it's crazy. Let me tell you, when you get the sundial gathering, it is off the hook. 3 dozen people. It's moving, so I remember my dad setting pebbles up in the parking lot and watching the shadow move while we were waiting for something or other to get ice cream. So this thing I thought had not affected me, the sundial weirdness. I thought I was fine. But I admit, summer before last, I was at the beach in Delaware, the first state, the Diamond State, and I found myself making a pizza box into a sundial. These are, if you're scoring along with us, these are hyperbole. Oh, are there any professors here? Anybody? They didn't have the guts, yeah. But just, if you can pass the word, when you do this, nobody, it doesn't help. Nobody's getting anything out of it. No, but these two lines, these are hyperbole. It's big fun. It's a multiplication of trigonometric functions. And anything that's on this table of the dial that is not used for telling time is called the sundial's furniture. In this case, my girlfriend colored in some sun things. I think that is my handwriting for the sunny hour. See, sundial should have mottos. That's just one of those things. That still in service. It's a wooden block with a gnomon. That's the thing that sticks up on a sundial. That's still accurate enough for Delaware. Then last summer, just a few months ago, I found a beer carton. I don't know where I got the beer carton. I just found it. It was also converted into a sundial for some reason. And there you see the sundial again. That block now 50 years old, still keeping perfect time. Fabulous. So at this point, you might ask yourself, is this guy suffering from SOD, from sundial obsessive disorder? If that is the case, let me just say it's not my fault. One of my dad's great ideas was to turn the Washington Monument into a giant sundial. Fellas! Huge gnomon, this huge stick, sticking up, casting this enormous shadow, and you can walk along with it. See what happens, you know, the pizza box, the beer carton, and then the washing line. After you reach a point where everything that sticks up should be a sundial. Okay, not everything. But fire hydrant, certainly. A lamppost, flagpole, yes. Somebody should be out there calculating and painting hour lines. Go, ice rinks, come on. Anyway, my father pointed out that there was at least one limitation. In the winter, the sun is lower in the sky than in the suns. And so the shadow gets very long, and we are going to have to move the White House. I mean, what? What's the big deal? You got to tell time. You're kind of taking my word for it. These lights are very yellowish, but if you look at the base of the Washington Monument, the shadow is gray. Yes, thank you, Bill. The shadow is gray. No, but believe me, if you look closely, the shadow is just slight blue, light blue, slightly light blue, slight blue, light blue, just a little bit light blue. And that light blue color comes from the Earth's sky. Now, most of us, everybody who's able-bodied, who has eyesight, can tell the difference between room light and daylight. But most people you meet cannot tell you why they look different. What is different about daylight from room light? Well, a lot of it is, on a sunny day, the Earth's sky fills in this blue color. See, when next time you're on the moon, you'll notice that your shadow is quite stark, sharp. Just black here, gray there, moon color there. But on Earth, it's not that stark. It has this gray color filled in from the sky and a little bit of blue. Now, we did not have this word in English, so I was forced to make it up. I call it cirrulescence. Cirrulescence. Isn't that happy? So, cirrulescence is of great interest in certain situations. Back in the disco era, 1976, the U.S. landed a spacecraft on the planet Mars, two spacecraft, the Viking spacecraft. And these took pictures of Mars. And as I said, if the thing had landed on one of those rocks crooked, we never would have heard from it. But it landed successfully, sent this picture around the world. Chicago Tribune, New York Times, Papua New Guinea Gazette, Oslo Journal, all over the world. And you will note that the sky is blue. And apparently it was a day and a half before one engineer said to the other engineer, you know, I don't think the sky is blue. And the first guy then says, well, it's a planet. But it's a different planet. So apparently they were looking at the shadows. They looked at these edges. And I paraphrase. Huh? And so they realized the sky's not blue. It's probably this color, whatever that is. And by the way, yes, apparently the U.S. flag was instrumental. They have these color coupons down here, and they were supposed to be looking at those, but they were really looking at the flag. So that color, what is that color? It's orange, tan, maize. Is that what you said? Ecru, yeah, eggshell. You know where they sell women's stockings? It's in the upper right. I don't wear women's stockings. I'm a huge fan. But yeah, big fan. So I got involved in this thing because I grew up with the sundial business, and I got involved. I got asked to be at a meeting at Cornell because the professors had kids who watched the Science Guy show, like you. Thank you. And so they took me there, and they had this thing. Target. That's what that is, photometric calibration. Yeah. If you don't know, you're stupid. Anyway, no, this is the test pattern for the cameras. So it's a little bit subtle. Mars is just crazy cold. I don't know if you noticed. It's crazy cold. And you don't want to violate the prime directive by contaminating the other world. So you can't send bacteria from Earth to Mars, or you're trying not to. So they bake the thing, they bake the whole spacecraft at these very high temperatures to kill the bacteria mercilessly. That's the bacteria. Anyway, so they get the colors, they color these rubber coupons, and then they bake them really hot, and they fade, and then after all they stop fading, so the nature of the pigment stops. But they also had this shadow, a tinge of yellow. Come on, people, it starts with an X, it's sexy. Same the destinies. So I'm in the meeting, and I realize they have this metal stick that they're sending all the way to Mars. And at first, my feeling is, aren't there other things that cast shadows, like antennas, wire bundles, bolt heads, those little exploso squib things that they unspring apart? And the distance unspring apart. And they said, no, we got to cast our own shadow of a specific width that has to fall in these rings. Wait, you guys! We got to make the photometric calibration target into a sundial. Come on! Yes, and they're looking at me, with concern. Bill, Mr. Nye, it's Mr. Nye, right? Because we all have PhDs, we're all doctors. Mr. Nye, we don't use sundials to tell time. We have, Bill, I see you're wearing one. No, it'll be cool! We can reckon time on another world! Come on! It'll be fantastic! It'll be like those guys who speak Klingon! It'll be real! Yeah, see, I see the ladies looking around. Now they're here.
Oh man.
Bazinga.
Called me out on that one.
Steve Squires, the principal investigator, he thought about it for a little while, a couple days, he said, okay. So my friends, there are sundials on Mars. This is a picture of Husband Hill, named after Rick Husband, one of the guys killed in the Columbia wreck. And if you look down here in the lower right, there's our happy little Mars dial, right there. So we took the photometric calibration target and dressed it up a little bit, and it also serves as a sundial. This picture is from the Curiosity rover just the other day, and way back in the distance there is Mount Sharp. It is, of course, deceptively far away, all these big landscapes. It's like the Midwest, only more so. But it is striking. Whenever I look at these pictures from this other world, it looks like a place. I mean, if you were dressed properly, you go walk around, right? I mean, you'd want some nice boots, and it's a camping trip. You want food and water, and important also, everybody, if you go, take something to breathe. As far as we know. And when you look up close nowadays, there's a picture of the Mars dial. This is the third Mars dial. The first two went on the Spirit rover and the Opportunity rover. This is on the Curiosity rover, and it was the flight spare. The budget is so tight. How tight is it? He took it out of this guy's drawer, Jim Bell's drawer, had it in his desk drawer. Jim Bell used to sit in Carl Sagan's office, by the way, same office. And it is really something, you guys, to hold something in your hand and then realize it's on Mars. It's a little weird. I mean, you go and you throw something overboard in the lake, it goes to the bottom. You know it's still at the bottom of the lake, right? I mean, that's what they do on the CSI. That's their whole thing. Lake. But when it's on Mars, you can't do it. So there's 3 rovers on Mars in this series, in the Sojourner rovers, 4 altogether, 3 with Mars dials. So because the Spirit and Opportunity rover are still roving, well, Spirit quit, but Opportunity is still roving. 8 years past their warranty. The program is now $450 million each. Now it's a little over $1 billion, and then dollars. And Curiosity, that new rover, is about $1.5 billion. Those 3 rovers sitting there are worth $2.5 billion, and they're not even locked. Anybody can just walk up.
No.
So if you look down here, I'm kidding. It's engineers. Okay. But if you look down here, I think you can see the slight tinge of ecru, orange, salmon, pale orange-descence, right there. I'm working on the spelling of this word. I had an A in Latin or Spanish would be but I think it's pretty good. Okay. So the shadow has a little bit of length in this picture. So it's the afternoon on Mars. By the way, here's my Klingon friends. There's a word for a day on Mars, a sol, S-O-L, like soul, like the sun, solar. But we don't really have an official word for hours, if there are going to be hours. Mars hours, Mars hours, hours. So you can work on that. But let's say it's about 4 in the afternoon, right here. 4 in the afternoon. And then, it takes several minutes. It's 14 minutes at the speed of light to get the picture back from Mars, and there's blade. So just a few minutes later, it's like 4-ish. But the thing really does cast a shadow, and it really is, big, stupid fun. Now, I want to, here's the motto, by the way, to Mars to explore. Okay. The other 2 dials have 2 worlds, 1 sun, which is pretty cool. See, sundial my dad would tell you sundial should have a motto. I only count the sunny hours. Or, like if you go to some some hippie school, like in Oregon or something.
Shimer College.
Life is but a shadow. So, and then in France, it's actually quite common in France. It says, the key word is blessant, but anyway, it says, every hour injures. Every hour injures, your last hour kills. It's a sunny day. It's existentialist Camus and The Stranger, and existentialism. Life sucks. Then you die. Anyway, okay. I just want to reassure you, taxpayers and voters, I did do something. All right? I did the vibration analysis on the gnomon, on the stick. And the reason it's so thick, it has to be thick enough to get enough pixels of shadow. And so it's not the best sundial, but it's cool. Anyway, the thing is indestructible. I started out in vibrations. This plane flew real near my house the other day when they brought the Endeavour space shuttle to Los Angeles. Anyway, I worked in the horizontal stabilizer, had a vibration problem right there. And it took me 3 years to convince my bosses that we needed this tube. I just want to look, if you're ever on a 747, let me reassure you, it's very well supervised. Don't worry. They made sure I didn't mess it up. But I did the analysis on the gnomon, on the aluminum post on the Mars dials. The thing's indestructible. I mean, you could tow a truck with it, what have you. But somebody did send me this picture. Yeah. There's winds on Mars. And then I realized it was April 1st. Crazy kids with your Photoshop. You're nutty, you're kooky. But whoever did it, I just want you to know you did just suck me in. I mean, I was just going to blow my brains out. It all worked out. Now, you may wonder what is the point of this story, this extended dance mix about the sundial. We all take it for granted. And my claim is that there are things happening right under your nose all the time that we're not aware of, and those things could, change the world. We all take it for granted. You go to the bookstore, and you can get a calendar with puppies and ducklings on the calendar. You can get puppies and kittens on the calendar. You can get the cheerleaders. You can get the firefighters with no shirts on. You can get all of that. And 2012 is a leap year. And we all take it for granted. Oh yes, there's going to be a February 29th. Oh sure, what could go wrong? You know how complicated it is. That's all I'm saying, Steve. I mean, these guys, the people who figured this out, did it by dint of just careful observation, generally of the shadow of sticks. If you've never done this, I encourage you to go outside and observe the position of the sun at the same clock time every day for a year. Ha 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 ha. All right? And this pattern is what you will see. And when it's straight up and down, that's the traditional place or time of day, rather, to measure it is at noon, when the sun is highest in the sky, and astronomy or sundials would say when the sun culminates. And so, this pattern is a result of, first of all, living on a big ball, which we do. A big ball which is 4.5 billion years old, something like that. And about 6,000. I will take questions at the end of this, by the way, so please stay tuned if you want to talk about that. Then the Earth's orbit is a little bit out of round. It's a little bit elliptical, a little bit eccentricity. And so this is what led to the precession of the equinoxes and those patterns of this pattern being printed on the sides of globes in libraries and classrooms, and our system of timekeeping, which I claim has had more effect on us, our society, than the invention of the wheel. I mean, if you live where trees fall over and it's pretty, and you got some open space, inventing a wheel is not that hard. If you live in a jungle where everything's too rocky and rugged, you never get around to a wheel. But timekeeping, calendars, that has, dare I say it, changed the world. So I'd like you to consider participating in the Earth Dial project again. The Planetary Society. You guys know I have a day job. I'm now the executive director, the CEO of the Planetary Society, the world's largest non-governmental space interest organization. Right on. We want you to build a sundial 10 times the size of the ones on Mars. The ones on Mars will fit in the palm of your hand. This one's 80 centimeters instead of 80 millimeters. It fits on a card table, 34.5 inches back in the ancient English system. And then people all over the world will build these things, as we did several years ago. And you can see the pattern of the hour lines changes depending on where you are on Earth. And it really is fascinating. And most people take it for granted. And I want you to just try it and then set up a camera and take a picture every now and then and send it to us at the Planetary Society, and we'll post it. So the ball on this thing is a ping pong ball, 40 millimeters. Apparently ping pong balls are available everywhere in the world. Even in developing countries, you can get yourselves a ping pong ball. And we have the dimensions, and there's a calculator on the website. And if you do all this, yes, my friend, we will send you a Space Geek button. Yes. All right. The sundial thing fascinates me, and it's an example for me of the science that's around us every day that we take for granted. But now we gotta take it up a notch, and I need you all to change the world. So let's say this picture of the sun represents the sun. This picture of the earth, if you can use your imagination, represents the earth. Now, if you ask any astronomer how far is the earth from the sun, he or she generally will give you this average number that we like to throw around despite the elasticity of the Earth's orbit. And we call it 1 astronomical unit, 1 AU. And it's very easy. Go up to an astronomer and you say, AU! How far is the Earth from the sun? And she'll say, AU! And that's right. So it's 150 million kilometers, 93 million miles. Mars, 1.5 astronomical units. Mercury, only 40%, 0.4 astronomical units. Venus, 0.7 astronomical units from the sun. Now you might quite reasonably expect Mars to be colder than the Earth as it's farther from the sun. Yes, and it is. It's so cold on Mars. Okay. The ice caps are not water ice. There's a little bit of water. They're dry ice. They're frozen carbon dioxide. Mercury is so hot.
How hot is it?
It's 350 Celsius. It's pizza oven, more than a pizza oven all the time. Yet, there's ice in a crater in the North Pole of Mercury. What's up with that? It's in the shadow, and they, if there are any Mercurians, have no atmosphere. So they can have these extremes of hot and cold existing in the same place, because once you face the icy blackness of space, man, it is cold. And once you face the sun and you're that close, it is freaking hot. So the Earth, as you know, is pretty warm. I mean, we're coming on the time in Chicago. You may question that, but generally it's pretty warm. Venus is crazy warm, exceptionally hot, deadly hot. And the reason for that is the Venusian atmosphere. This is a picture from Mars with the Sojourner rover, which landed in 1997, which was, I guess, was Nirvana's third album. Yeah. So it was a very important time. Well, in a sense. And it was a big deal on Mars. This happy little rover landed there, and you can see there's the Martian sky. And on this mission, the instruments on board took these data. The Martian atmosphere, the atmospheric pressure is about 0.007 of the... oh, by the way, thank you all for coming instead of to see Skyfall. I will see it. I've got a problem. I got a monkey on my back. I do like that. And I know everybody likes the new guy, Daniel Craig. Yes. Good. Both boys and girls like the new guy. 7 thousandths of an atmosphere. And you may know that there's a fabulous old unit called a bar, which is about an atmosphere. It's based on square centimeters and kilos. So it's not used anymore. Now, instead of a millibar, it's called a hectopascal. Hectopascal. So I'm proposing maybe you guys have some 7 heps. So the Earth would be 1,013 heps. All right, you can look at these data. Okay. This is the composition of the Martian atmosphere versus the terrestrial, the Earth atmosphere. And you can see that Mars is 95% carbon dioxide, even though it's at this extremely low pressure by our standards. The Earth is only 0.03%. 0.03, not 3%, 0.03%, which is 300 parts per million for you exponential multiplying buffs. And you all were alive. Everybody here was alive when that number, 0.03, rounded to one digit, changed from 0.03 to 0.04. in our atmosphere. Went from 330-ish to now it's 392 generally considered parts per million. And that tiny change, in which seems like a very small fraction of what might even be an insignificant gas in the Earth's atmosphere, that tiny change is changing the world. And that's where I want you to get her done. Now, we compare this to Venus. Venus is 90 atmospheres, 90,000 hectopascals, and it would crush you, like if you went out of the submarine really deep. Now, if you guys haven't played this game in a while, I hope you remember where, excuse me, you can't step on the floor because it's lava, and you can't drink out of the sink because that's like acid. It comes out of the faucet, and it will kill you. Let me tell you something. On Venus, it's really like that. The Venusian atmosphere holds it. Oh, by the way, Venusian is the modern adjective in the 19th century for things having the characteristics of or pertaining to Venus. We use the word venereal. That it was supplied in other ways. Because everybody thought Venus was going to be the goddess of love, and everybody's going to show up and be this lush, tropical thing, and beautiful people. And instead, it would crush you like this. Your fishing weights would melt. Lead would melt on the surface of Venus. And so the Venera spacecraft, which was sent by the Soviet space agencies, now Roscosmos, it lasted less than an hour. Took a couple pictures, and it was really an amazing thing. But now, there are no more missions to Venus, but Venus, the Venusian atmosphere, is where people really became aware, really quantified, really came to understand the greenhouse effect. That which allows visible light to pass through the atmosphere, hit the ground, re-radiated as heat, and that infrared does not go back into space nearly as fast. Certain gases, carbon dioxide, water vapor, methane, hold that heat in. And the discovery of that was on Venus back in the 1980s, really. And so this tiny change in the Earth's atmosphere is changing the world. Maybe you heard about this. We had this storm, Sandy, which came ashore on the eastern seaboard. I was in Florida, and there was a beach in front of me 1 minute, and then there was just erosion. That the green just stopped. Stuff just disappeared. Long Island was underwater in North Carolina, even though North Carolina wasn't hit directly, it was just underwater, like that. And I don't know if you remember this, last February, we had tornadoes right outside of Dallas in February, not in July, in February. There were tornadoes in Brooklyn that wiped Brooklyn. I mean, it's not, seriously, not Oklahoma, Brooklyn. And then the one that really got me, I was standing there in the airport, and there were flying trucks outside the airport. These semi-tractor trailer trucks were picked up and thrown in the air as though they were matchsticks. Now this change is what you guys are going to have to deal with. These phenomena are going to become more and more frequent because there's more and more heat energy in the atmosphere. And the people who are going to solve these problems and save the world for humankind are you. You are going to do it because you are the scientists and engineering managers of the future who will change the world. This will not work. This is a law passed in North Carolina. And they're going to only allow the measurement of sea level rise after the year 1900. They're going to legislate that. These data shall be limited to the time period following the year 1900. So even if the sea level's rising, they are not allowed to admit that it's been rising. Okay, good luck with that, guys. Invest in seawalls. Now, North Carolina obviously has a lot of skeptics. But that was just last July they were messing with that. Has a lot of skeptics. Now, if there are climate change skeptics here, there might be, I encourage you to do what I did. Go to the Ice Core Lab in Glendale, Colorado. Glendale, Colorado, not Glendale, California. That's like a whole nother, that's like in the valley. It's literally different. Glendale, Colorado, there's like shopping malls, it's right? There's lots of parking. So you go to the Ice Core Lab, and it's this enormous building. I mean, it's a quarter-mile long, and it's just cold inside. I mean, not Chicago, I mean cold. And I said to Todd Hinckley, the guy who runs the place, I said, now why did you pick 36 degrees below 0 Celsius? He says, Bill, I didn't pick it. I just turned the thermostat all the way down. No, Bill, I just turned it. So anyway, there are these enormous pieces of ice that people have drilled out of the ice sheet in Greenland, and Siberia, and Antarctica, Kamchatka Peninsula. And you look at them, you take them in the warm room, which is only 27 now. Well, you guys are Chicagoans, this is nothing heavy. You can take your hood off. Wow. But after a minute or two, it's pretty freaking cold in there. You don't have to know anything about anything. You can count layers of ice. They're about this long, about 10 centimeters. And they're a result of layers of snowfall every year in these places that are cold and it snows all the time. So you take these pieces of ice and you sky them, you cut them in half, and then you look at them under a microscope, and you will find little grains. You go to Greenland, you'll find grains of sand from China that are blown all the way around from the Gobi to southern Greenland. And then if you slice them very carefully, you will find these tiny bubbles, ancient atmosphere. So what would you guys be doing if you weren't here? You'd be watching CSI, CSI Lafayette, or CSI. Do they have one? CSI Rockport. Yeah. Is there CSI Chicago? I don't even know. No, not yet.
Chicago.
So the tines of the snowflakes trap bubbles of atmosphere, and then as more snow falls on them, they crush together. There's a little mechanical breaking of the tines, and they release a little heat, and it melts. There's a fabulous word, redulation. The ice turns this clear, and you can see the little bubbles. Now, if on CSI Rockport, if the guy has the blood on the shoe and the carpet fibers, he was in the room with the dead guy. I mean, that's it. That's the evidence. We're done. Okay, if there's bubbles in the ice, they didn't come, nobody's running around with a hypodermic needle squirting bubbles. That's it. The bubbles are in there. That's the ancient atmosphere. And wait, there's more. All you do, you melt the ice, and you take it to your mass spectrometer, like you have at home, and you count neutrons. And when the sea surface is warmer, more water molecules with lighter weight oxygen atoms, about H2O, evaporates, and you can calibrate the number of neutrons correlate perfectly with the sea surface temperature as measured by other conspiracy organizations like the U.S. Navy and so on, and it comes out fine. So this leads to the famous graph. I hope you're all familiar with this. This is the world's temperature the last 1,000 years versus time. So this is the famous hockey stick where for centuries the Earth's temperature was nominally pretty constant, but in the last couple centuries, the last 200 years, the world's temperature has increased very fast. This is what I emphasize to everybody. It's not just the amount of carbon dioxide or the amount of warming. It's the speed that it's warming. That's the thing. It's the speed that is going to cause you to change the world. Yes. Now here's why it's happening. I just want to emphasize this to everybody. This is the International Space Station. Actually, it's a picture of the International Space Station. It does not fit in this room, and it's all, if you know, it's made for space. It's very fragile. It would sort of crush under its own weight. It'd be very expensive. Well, hold it. The whole thing. There's problems all around. We have to get it in space first. Yeah. So if you showed this to my grandfather, he would think it was out of focus. He would think, first of all, he wouldn't believe you took the picture, but he'd think it's out of focus. But that out of focustivity is the Earth's atmosphere. So if we had some extraordinary car on an extraordinary road that could drive straight up, you'd be in outer space in an hour and a half. I mean, it's right there. The atmosphere is only this, that's it. Now, it's thin. When I went with my family to the World's Fair in 1965, the U.S. population had grown, was 192 million. 192 million. Today, the U.S. population is 314. I took this picture, captured this earlier today. Almost 315 million in my lifetime, 1965 to 2012. We had just missed this other total board of the world's population. Now I'm with my dad, all right, the guy who slows the car down and takes his camera out to take pictures of the odometer as it changes from 99,999 to 100,000. And the cop pulls him over and says, "Sir, well, I'm taking pictures." "Oh, very good, really." I was with a film camera. They had this system with clear plastic and emulsions of chemicals that were sensitive. But anyway, we missed a changing from 2,999,999,999 people in the world to 3 billion. Well, today, my friends, there are over 7 billion people in the world. So those two things, the extraordinarily thin atmosphere and the number of humans, that's how we are able to change the world's climate, by accident. So what you could do at this point in our story is run in circles screaming. Generally not that effective. What I want you to do is change the world. So, this is the Golden Gate Bridge. Actually, it's a picture of the Golden Gate Bridge. It's made of steel. Steel is fabulous material. Chicago is built out of steel. I rode here on the train from the airport on steel rails, steel wheels. Of course, not the love. Springs. There's a spring in this thing, steel. It's great. But I had the extraordinary experience of meeting bricks. What'd I do? Whoa! Whoa! Wait. Steady. I'll bet you when I put this in here, this happened. 3, 2, 1. All right, people. Let's see. It isn't one thing, it's something else. Oh, now, what the devil? I could unplug. Seems extraordinary. Stand by. You can unplug. Stand by. Still frustrating. Still hilarious. Ready? Ready? Yes. It's working. It's working. Oh, hang on. Big boys. No, we're going to figure this out.
No, if he calls OTS, he's
I
sus.
wonder if in this excitement, the thing just went black. Wow. This one didn't have this. Okay, stay. Stay. Maybe we can do it from here. 3, 2. This, for those of you who choreograph fight scenes for movies, this right here, you want the trickle of blood. That's all that happens to a guy. Right? One trickle of blood. One trickle from life, broken pieces. I met Rick Small. And Rick Smalley, unlike many of us, had a Nobel Prize. Anybody? Either one? So, oh yeah, then we gotta do this. Stand by, wait. Okay. Yes! So, Rick Smalley was a guy, he's a chemist at Rice University who had been challenged by the astronomy department to figure out what molecule they were observing in deep space. They thought it was carbon monoxide, but that didn't quite work out. They kept screwing around with carbon monoxide, it wasn't it. And then Rick Smalley told the story to me on camera, very compelling, fabulous way. So he woke up at 3 in the morning and he had it. Instead of carbon with oxygen, there was carbon with carbon, with carbon, with carbon, 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 with carbon, with carbon, with carbon. 60 carbon atoms together in a sphere, which he called Buckminster Fullerenes, named after the architect who really promoted geodesic domes, like you have, like, where lights put a shadow. It's the pattern of hexagon, pentagon, like on a conventional, traditional soccer ball. And so his dream was to have a soup of carbon and pull the spheres apart and grow these tubes. Are you guys growing nanotubes here? Who wouldn't be? Anyway, they're 10,000 times stronger than steel. I'm sorry, what did you say? I did. I said 10,000 times stronger than steel. But they would only weigh a sixth as much. And if you guys are doing it, you can only get them like 50 nanometers. But his dream was to make these things meters, tens of meters, kilometers long. And then everything that we think of as being made of steel would then be made of carbon. And we would change the world. And so Rick Smalley was really the first guy that said to me, the key to the future is not to do less, but to do more.